Hello everyone, welcome back. Today we're going to be doing a critique of last week's coding challenge, which was episode 3, season 4. So let's get to it. In last week's challenge, we continued on with our Blackjack Blackjack project, and you had to implement 4 methods. Hit, which basically gets a card from the dealer. Get hand, which returns all of your cards. Is busted, which returns either true or false, whether or not your hand is busted. And get hand value, which returns the total value of all the cards in your hand. So, all of you implemented an internal data structure hand as an array list, which I think is probably the best for this problem. The only other data structure that we taught you was a dictionary, but it doesn't make sense to use a dictionary here. If you're wondering why, or if you're not sure why an array is better than a dictionary for this, leave us a comment below, and we'll answer you and get back to you that way. So the first method was hit. So this is one submission from a student, and this student did 2 calls, called a get and a remove on the Blackjack's deck. And while this works, this is not necessarily the best solution. And the reason it's not the best solution is, a couple of reasons. One is that Blackjack already has, last week we talked about this. We have 2 calls here, get and remove. And remove actually returns to you the card that's been retrieved as well. So the remove call makes the call to get sort of redundant, because you're doing get and then remove also does a get for you. So just calling remove on its own is adequate, because it does a get for you. The second reason why this is not the best solution is because if we look at the Blackjack class, there's a method defined in there called draw, and if you look at the implementation here, draw actually does the remove for you already. So why implement the same thing when you can use something that already implements it? And you might ask, well, here remove only does, it's just 1 line, so you're not really saving much. True, you're not saving much in this example, but what if draw was something more complicated? Then number 1, you'd be duplicating a lot more code. But number 2, which is more important, is that draw hides for you the implementation details of how you do the draw. Here we know that it does a remove. But what if it was something else? What if the data structure is for deck is no longer an array, if it's something else? Draw hides all of that for you, and if the implementation changes, then this code here will break. Well, but if you call draw directly, like here, then the implementation could change, and it shields us. Our code still works because the Blackjack class has an external contract, a public API that tells us that whenever you call draw, it's going to take the next card and give it to us and remove it from the deck. That's all we need to know. We don't actually need to know that it's actually implemented using a dot remove. So we should call dot draw, because number 1, it reuses code. It helps us not duplicate code, but more importantly, it shields us from the implementation details. Okay, so I hope that makes sense. If it doesn't, leave us a comment and we can continue the discussion that way. Okay, the next method that was supposed to be implemented is get hand, and I think most of you did this. Basically, you just returned the hand array. Okay, is busted is also pretty straightforward. It checks to see if the total value in your hand is greater than 21. If it is, then you're busted. If not, then you're not busted. So most of you implemented something like this. Now, as we talked last week in our critique, there's another way of doing this, and this is using a ternary operator. It's a little bit more concise, but for those of you who this might be new to, ternary operators might be new to you, then it looks a little bit cryptic, but it's actually very commonly used. So if you haven't seen last week's critique, please take a look at our critique from last week, and we explained this a little bit more. Okay, Now, then we get to get hand value. There's a number of different ways to solve this. We had a number of different submissions. This is from one student. I wanted to highlight this here. So let me walk you through what happens in this code. So there's a property that's an int called hand value. And then if we jump to the bottom, there's also a method called get hand value. Okay, the property hand value presumably is supposed to always contain the total value for your hand. And then the method get hand value is supposed to return that. Okay, so inside get hand value, the code here actually goes through all of the cards in your hands and calculates the total value and then stores that in the property hand value. Okay. Now, what's the problem with this? Well, actually, let's talk about is busted. So is busted needs to check what your hand value is and returns true or false. So because we have the property hand value, we can't just check the value, compare the value of the property hand value immediately because it may be out of date. And because it may be out of date, then is busted calls get hand value first, because get hand value actually refreshes and recalculates and guarantees that the value of the property hand value is always up to date after you've called get hand value. So we basically call get hand value first to refresh the property hand value, and then we use the property hand value in our comparison. Okay, so there's a number of problems with this code. First, there's a bug. It actually doesn't work. The comparison is reversed. So that should be a greater than. And the second thing I wanted to point out here is that the property hand value is not initialized. In this case, it might still work because Java most likely initializes it to 0 for us. But in best practices, it's always good to initialize a variable when you first declare it. So here this shows an initialization to 0, and we've corrected the bug in the return in is busted, so it should be greater than. Okay, so that's the first two problems. Now the other problem is a little bit more philosophical, and that's get hand value. It doesn't just return hand value here. It also has a side effect of updating the property hand value, and it needs to do that because hand value could get out of date whenever a new card is added to the hand. So it does that, and so is busted is calling get hand value because it depends on this side effect. Okay, so whenever you're calling something because you're depending on its side effect, that's already a red warning flag to me that you're not structuring your code properly here. Because number one, there should be no side effects. Number two, your code should not be depending on a side effect. Okay. So that's a problem. Another problem here is that if you look at the get hand value, it actually returns the card already. It returns the total value when you call get hand value. So we don't actually necessarily have to use the property hand value in the return inside is busted, because get hand value already returns that. So that's the second problem I wanted to highlight here, is that we have two sources of truth. What am I talking about? We have the truth. We want to know the total value of your hand. So that's a truth that we want to know. Now here we have two sources of truth. We have the property hand value, and we have the method get hand value. Both of those is supposed to give us the total hand value. Okay, so whenever you have two sources of truth, that's already another red flag. And that's because if you have two sources, then either those two sources have to always be in sync, or one source is dependent on the other source, right? We can't have two independent sources of truth, because then they can get out of sync, and then that's a problem. Now you have a problem in your code, and that's a bug just waiting to happen. So we're going to get back to this. I just wanted to show you one other submission here. So this other submission actually addressed the problem differently. In the previous submission, what we're doing is we're refreshing the value of the property hand value on read. So whenever we're reading the value by calling get hand value, or refreshing the value of the property. This other submission approached it differently. Instead of refreshing hand value on read, it refreshes it on write. So whenever we're changing the card array, so in this case we're adding another card to the array, then we're refreshing the value of the property hand value. Okay, so both of those are valid approaches. There's different pros and cons. In this one here, when you're doing a refresh on read, then wherever you're reading the hand value, then you need to refresh it. In this case, if we only had one source of truth, get hand value, then this makes a lot of sense. Now the pros and cons of this one, we're doing a refresh on a write. So that means whenever we do a write on the hand array, then we need to refresh hand value. So if we have, if let's say this were Blackjack, if this were poker and you can discard cards, then that would also be an update on the hand array. Then we also need to do a refresh there. Okay, so if we have multiple places where we're needing to do a write, and we only have one place where we're doing a read, then most likely it makes sense to do a refresh on read. But if conversely you have multiple places where you're reading and only one place where you're writing, then a refresh on write probably makes more sense. Okay, so just a quick sidebar there. Now, both of these still have the same problem in that you have two sources of truth. So if we can remove one source of truth and just have a single point source of truth, that would be best, right? That removes the potential of these two getting out of sync and introducing a bug. It also reduces the need to make a decision on whether it's a read on refresh or a write, a refresh on read or a refresh on write, because we don't actually need to refresh this second property anymore. Okay, so the best solution would be something like this, where we just have a get hand value as a single source of truth. It recalculates the hand value, but we don't store that hand value in a property at all. There's no need to store it. Whenever we need to retrieve the value, we recalculate inside get hand value. So now we've boiled it down to just one single source of truth, which is a very good design. And then whenever we need to use the value, like in this case is busted, when we need to check the value, then we call get hand value. It always recalculates, so it doesn't matter how many times the card hand array has been updated. Whenever we need to read the value, we will always recalculate. Okay, I just want to show you one more thing. One student did something similar to this, but they did something different. Inside get hand value, when it's calculating the total hand value, it accesses the card.number property. Now, if we look at the card class, we already have a method called getValue, and in there it does the parse int for the number property. But you'll see here that there's actually a bug, because in this implementation, it doesn't take into account that you can't parse the number if it's J, Q, or K. That'll actually cause a crash. So this solution here works if your hand is all just numbers, but if you have a face card, then this would crash. Or it won't work. So again, going back to what I said earlier, if there's already a method, in this case get value, that you can use, then use that. Don't access the property directly. In this case, it shows you exactly why we want to do that, right? Because inside get value, it takes into account that some of the cards may not be numbers. Well, in your implementation, in this student's implementation, it didn't. So in this interface here, presumably this code already works. It's already been debugged. So when we're reusing code like this, we're leveraging the fact that it already works and it's already been debugged. If we're re-implementing it here, then we have to go through the whole process of making sure it works and debugging it again. And why do that when we can reuse code? Okay, so that's a big case for code reuse. All right, so then the actual solution, or the best solution that I think, would be this. It addresses all of those issues. So hopefully this makes a lot of sense to you. We talked through a number of different best practices. We also talked through a number of different Things to consider: good design choices like a single source of truth, reusing code, leveraging code that's already been tested and debugged as opposed to reinventing the wheel. Looking through the interfaces of the classes that you're using and making sure to only use the public interfaces and not use internal implementation details. Don't depend on side effects. So number one, your code should not have side effects, but number two, you should not be depending on the side effects. Always use the clearly defined external interfaces. So all of these are good design and coding principles that in this week's coding challenge, which is simple, but it was a good illustration of all these principles. All right, so if you liked this video and it was helpful to you, please give us a like, a thumbs up. If there's something that didn't quite make sense, leave us a comment and we can answer you that way. All right, have a good day and talk to you soon. Bye-bye.